Hello Chem 152 students, and welcome to the very final lesson of our experience in General Chemistry 2 during this crazy global pandemic of ours. Last video we covered unsubstituted alkanes, which are basically molecules of just carbon and hydrogen where the carbons are single bonded to each other. Today we will get into substituted alkanes, specifically two different kinds. Kinds where one of the hydrogens in the molecule is replaced with an OH group, that would be an alcohol, and or where one of the hydrogens in the molecule is actually substituted for a NH2 group or an amine. Now, functional groups, these essentially give organic molecules different functions. As the name implies, they can do different chemistry. And in this class, this is meant to only be a slight preparation / introduction for organic chemistry, should you desire to go on. Now then, going into, say, the first of the alkanes, where methane would be a single carbon molecule that is bound 4 times to hydrogen. Well, if we were to take that root word methane, we can use it to form different names for, say, an alcohol or amine of methane. Let's take the situation where we take our methane molecule, but we substitute one of those hydrogens for an OH group or an alcohol. Well, when you are naming an alcohol, you take the root word, which in this case would be methane, because we have a single carbon, and we are going to replace it with an OL suffix. So in this case, we went from methane, an alkane, to methanol, where an OH group is substituted onto the molecule. Now in the case of the amine, we have again a molecule that has only one carbon in it. Therefore, we are going to keep the root word methane. But since we have a functional group that is an amine, we are going to end this word with a suffix of amine. So in this case, our molecule is methanamine. So in this case, in this slideshow, we did the first of the alkanes, which would be methane, and we formed methanol and methanamine by basically replacing one of the hydrogens with either an alcohol or an amine functional group. Going on to ethane, in this case we are getting larger molecules. We can talk about the line structures for these guys now. But first and foremost, let's name this. Well, for the plain Jane alkane without any functional groups, we are dealing with a 2-carbon molecule. That would be ethane. The root word 2 carbons is basically represented by ethane. And if one of those carbons has an OH group attached to it, instead of as many hydrogens as the plain Jane alkane, we are going to give that new molecule the ending OL or OL. In this case, the terminally substituted alcohol version of ethane would be ethanol. Now, for the amine version, the amine substituted version, well, we are going to still have a molecule of 2 carbons. Therefore, the root word will still be ethane, but since the functional group is an amine, it'll be ethanamine. Now, to basically represent that as a line structure, we essentially will continue with 2 points for the carbons, but we will draw a bond and then represent the whole functional group. We won't leave out the hydrogen for a functional group, just to keep things clear. But the hydrogens that are attached to the carbons, we will just keep them invisible and assume that they are there. For the line structure of ethanamine, we are going to have 2 points for our carbons, and then drawing from one carbon a bond to our NH2 group. Moving on to the 3-carbon variant, the 3-carbon series. For the plain Jane alkane without any substitution, the name of that molecule would be propane, because propane means 3 carbons, where the ending E or ane in this case means there's only single bonds. Now, in the case of the alcohol substitute terminally substituted propane, we are going to change that molecule from propane to propanol, because we now have an OH group at the end instead of just having hydrogen. And in the case of the version of propane, where we still have only 3 carbons, we will keep the propan root word, but replace the ending with amine, therefore letting us know we are dealing with a molecule that has only 3 carbons, and at the end we have an amine group. So for example, if I ever on the test ask you to write out, if I ever tell you the word propanamine, then you should be able to, from the name, know that we are dealing with a 3-carbon molecule that has an amine group at the end. And the line structure for these two guys will simply be 3 points for the carbons, and then a bond going to the functional group. For the alcohol, it would be an OH, and for an amine, it would be an NH2. Going on to the butane series, butane is once again a simple alkane that has only 4 carbons. That is what the butane root word implies. For the alcohol substituted version of butane, we are going to name that butanol, because the OL is what is used to represent an OH group. And then for the amine substituted version of butane, we are going to have butanamine, where we simply removed the E in butane and added amine, A-M-I-N-E. And then the line structures, if we didn't want to write out the full chemical structure, would simply be 4 points for all the carbons. And in the case where there is a substitution, one of those N carbons is going to go to either an OH or to an NH2 group. Now to deal with the 5-carbon series, or pentane, well, pretty straightforward once again. Pentane would simply be pentane, a molecule that has 5 carbons, where the ane ending implies there's no substitution. So 5 carbons, there we go. Now if we were to substitute one of the hydrogen at the end with an OH group, well then we would call that molecule pentanol, because pentan means 5 carbons and an ol means an OH substitution onto the molecule. In the case of the amine substituted version of pentane, we would replace the final E with amine. Therefore we have pentanamine. And line structures, nothing changes from the typical format. For pentane, it would be 5 corners representing each carbon, and we leave out the hydrogens that are attached to the carbons. For the pentanol, we have 5 carbons, 5 points for each carbon, or 5 points representing all the carbons. And then the final point, since this is terminally substituted, will go to the OH group. Or in pentanamine, it will go to an amine group and NH2 group. And the situation is just pretty similar for, say, hexane, heptane, octane, nonane, or decane. Effectively, if you substitute an alcohol or an amine group onto your molecule at the end, then simply keep the root word and then replace the final E with either OL for an alcohol or an AMINE, amine, for an amine. And the line structures should be intuitive. For the bonus of this week, essentially, here's what I have for you to do. For this part of naming, essentially draw the chemical and line structures for octanol and octanamine. Octanol being the alcohol terminally substituted version of octane, and octanamine being the amine terminally substituted version of octane. Now then, and for the last part of the bonus, essentially tell me the names of these two molecules. One of them is going to be an alcohol, so the ending will be OL, and then the bottom right is an amine substituted molecule, so the name will have the suffix amine at the end of it. And this concludes our miniature preparation for organic chemistry. Should you guys want to continue on, I definitely recommend it because organic chemistry is without a doubt my favorite kind of chemistry to be involved in. And, well, here's hoping I get to teach it someday. Well then, guys, it has been a pleasure teaching you this semester, and I have nothing but pride and joy in the work you have been submitting. So at the 11.5-minute mark, I wish you guys a great end of the semester in this pandemic experience.